Hey guys, here are your notes on Chapter 8, Section 8.1, Simplifying Rational Expressions. So Chapter 8 is the last chapter that we'll get to this year, obviously, and we're only going to get one or two sections in, which is fine. It's an important section, and it brings back factoring, guys. So I keep telling you guys that you have to be able to factor, right? And what does factor mean? Break things up into pieces that multiply, right? So factoring is going to make a major comeback in this section. All right, so if we're going to be simplifying rational expressions, you have to understand what a rational expression is. A rational expression is one polynomial, and if you remember, a polynomial is just a really nice mathematical expression. It is one polynomial divided by another polynomial. So guys, at the end of the day, it's one thing divided by another thing. So it's a fraction. So a rational expression is just a fancy way of saying a fraction, okay? So let me give you a few examples of a rational expression. This is a rational expression. It's a one-term polynomial divided by a one-term polynomial. It's a rational expression. And we've already done these. We would divide our numbers and then subtract our exponents and put it back where the bigger one was. Okay, this is a rational expression. It is a two-term polynomial divided by a two-term polynomial, okay? These ones are a little bit harder to reduce than one like this. And these are the ones we're going to see a lot of in this section. So I'm going to go over what makes these ones harder than these ones. If you can see, one of the major differences between them is this one didn't have any adding or subtracting. These ones do. And that's the major key. Adding and subtracting kind of make it harder to work with. Okay? All right, look at this. This is a rational expression. It is a two-term polynomial divided by a three-term polynomial. Okay? All right, let me go over some basics with you. Since a rational expression is a fraction, then simplifying a rational expression is going to be like simplifying or reducing a fraction. There are a few major do's and don'ts you have to watch out for, so let's review a few things. Number one, a fraction is showing division, right? That's what a fraction does. It is the top divided by the bottom. Well, in math, certain operations go together. Division and multiplication go hand in hand. They are inverse operations, right? One will undo the other. And in fact, PEMDAS says you can do division or multiplication depending on which one came first, right? But it's not like you have to do this one first every time, all right? But I must warn you, adding and subtracting are very bad for simplifying or reducing a rational expression. Addition and subtraction, act like glue. They keep terms together like a package. And again, I'll go over this again. I just want to put this in your head. Let me say that again. Addition and subtraction, they act like glue. They keep terms together like a package. They're going to hold things together, okay? So because of that, addition and subtraction will be the enemy in these problems. They want you guys to kind of jump the gun, and you have to kind of warn yourself like, nope, I'm not going to do that. I know they want me to, but I'm not going to do it. So again, adding and subtracting are going to be the enemy in these problems. They're going to make it that much harder to reduce or simplify it, okay? And I will explain why, but just keep that in your head. Multiplying and dividing, good. Adding and subtracting, bad. Okay. So, because we're going to be working with all these fractions, let me show you why adding and subtracting end up being bad and multiplying and dividing are good, right? Okay, so let's review a few things about fractions. Well, this is what we hope. We want to try and reduce things or cancel as many things on top and bottom out. Let's make this fraction as small as we can possibly get it, right? So in math, when you take the top and divide it by the bottom, what's 8 divided by 8? What's anything divided by itself in math? It's 1. So basically what's going to happen, if something on top and bottom matches, it's almost like you're canceling it out and it equals 1. That's our goal. We want stuff on top and bottom to cancel out and go away. But the problem is it attached to whatever's next to it by multiplication, or is it attached by addition and subtraction? That's going to be the major key. All right, but let's look at this one. If we know 8 divided by 8 is 1, well then what's x divided by x? I don't even have to know what x is to know that anything divided by itself is 1. Okay, so again, an x on top and an x on bottom, they're kind of like canceling out and dividing to 1. All right, now watch this. So we have multiplication, and then we are dividing by 2. right? I said multiplication and division go hand in hand. Watch how we do this problem. Technically, this problem is saying to do 10 times 3, which is 30, and then divide it by 2. Well, what's 30 divided by 2? It's 15. The answer to this problem is clearly 15. So in math, we like to find a lot of shortcuts, but we can only use the shortcuts that don't affect the answer. It can't change the answer, right? So watch this. If I had done this same problem, watch a shortcut. Well, because this is 10 times 3 and then divided by 2, it's multiplication and then division, I'm actually allowed to divide first if that makes the problem easier. So technically, I'm allowed to do 10 divided by 2, which is 5, and whole numbers go on the top, and then I could times 5 with 3. And what's 5 times 3? It's 15. It gets me the same answer that I was supposed to get. So again, it's showing you that if you have multiplication on top, you're allowed to do division first and then multiply second, and it won't affect the answer. So again, multiplication good, it allows us a shortcut. But adding and subtracting will not allow that shortcut, okay? So if I'm allowed to do 10 times 3 divided by 2, or 10 divided by 2 and then times it by 3, then watch this. Technically, if I look at this problem, I have 10 times x, and then I'm dividing it by 2. So since I can't do 10 times x first, because I don't know who x is, I am allowed to divide first because it's just multiplication and division. So I am allowed to do 10 divided by 2 is 5, whole numbers go back on the top, and then I times it with x. And now my answer is 5x. So again, if it's multiplication, I'm allowed to divide first. Adding and subtracting won't allow that though, and I am going to get there. All right, so look here. This problem says to do 5 times 3, right? 5 times 3, and then divide it by 5 times 4. So if I do this problem the way it says, I can do 5 times 3 is 15 on top, divided by 5 times 4 is 20, and now I have one cohesive fraction, and I have to reduce it. We always reduce, right? So what divides evenly into both 15 and 20? It's 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. The answer to this problem is 3/4. Okay, but if I do this same problem again, there is a shortcut. See, it's multiplying, and division, right? I am allowed to divide first. So if you notice, what's 5 divided by 5 going to be? It's 1. They kind of cancel out, right? And then it just leaves you with 1 times 3, which is 3, over 1 times 4, which is 4, and I get the same answer I did over here. So the moral of the story is it's actually easier to divide your 5s out first, and then you're just left with your reduced fraction in the end anyway, instead of having to multiply and then reduce again. So if something matches on top and bottom, we're going to want to cross that out and make it go away, right? But the thing to notice is the only reason I was allowed to cross these 5s out is because they were attached by multiplication to whatever was next to it, right? So I was allowed to do the division first and then leave the multiplication for last. So again, that's nice. If it's multiplying and dividing, I have a shortcut. But guys, if this was pluses or minuses, watch how it doesn't work. You can't use this shortcut when it's adding or subtracting. You won't get the same answer, okay? All right, so watch. This problem clearly says to do 5 plus 3, right? That addition is holding this together like a package. I have to do 5 plus 3, and then I have to divide it by 5 plus 4, right? It's holding the 5 and 4 together like glue. It's a package. All right, so technically I'd have to do 5 plus 3 is 8 over 5 plus 4 is 9, and then I would look to reduce, but 8 over 9 doesn't reduce. So the answer is 8 over 9. However, they want you to fall into the trap of going, oh, look, 5 on top, 5 on bottom. Let me cancel those guys out, and then I'm left with 3 over 4. But guys, is 3/4 the same as 8 over 9? No. So when you cancel the 5s out now, when they're attached by addition, you don't get the same answer. So this is something that you're going to want to do, but you're not allowed to do. Please don't cancel those 5s out when they are attached to the next piece by addition. It doesn't get you the same answer. And that's a trap they want you to fall into. But you have to remind yourself that adding or subtracting is going to be our enemy. Multiplying, good. Adding and subtracting, bad. All right, so look here, even if I do it with subtraction. This problem clearly says to do 5 minus 3, right? It's holding it together as a package, and divide it by 5 minus 4. So if I do this, 5 minus 3 is 2, and then I have to divide it by 5 minus 4, which is 1. 2 divided by 1 is 2. The answer to this problem is clearly 2. But if I try to use my, oh look, 5 on top, 5 on bottom, let's cancel them out trick, if I tried to cancel the 5s now when they're attached to the next piece by subtraction, I get negative 3 over negative 4, which reduces to 3/4, which is clearly not the same answer as 2. So again, this is something you're going to want to do. You're going to want to cancel those 5s out, but you are not allowed to, okay? It does not get you the same answer that you're supposed to get. So again, adding and subtracting are going to be the enemy because you're going to be really tempted to want to cancel those 5s out, but you're not allowed to. You're only allowed to cancel those 5s out if they're attached by multiplication. Okay? All right, look here. So again, this is something you might see. So if you have x plus 3, right, it's hold together as a package divided by x plus 4, you're going to look at this and you're going to be like, oh, look, x on top, x on bottom. Let's cancel those guys out. That is so wrong. X plus 3 is held together by addition. So they're like a package. And x plus 3 could only cancel with another x plus 3, something that looked just like it. All right, x plus 4 is held together as a package. It could only cancel out with another x plus 4 on top. So again, you're going to really be tempted to cross these x's out, but you're not allowed to because of that addition. It holds it together as a package. X plus 3 is held together and x plus 4 is held together. So technically, if you ever saw that expression, it's already reduced. It would stay x plus 3 over x plus 4. It's already a reduced expression. There's nothing you could cancel out, okay? All right, but if you look here, all right, x plus 3, which I have to hold together, divided by x plus 3, right? Well, even though the addition is holding this together like a package, x plus 3 is being held together again. What's anything in math divided by itself? So x plus 3 as a whole divided by himself, x plus 3, now they're allowed to cancel. X plus 3 divided by himself, x plus 3, it divides to 1. So again, only an identical package on top and bottom can cancel out and reduce with each other. All right? All right, so I hope that helps. So I wrote here, the major moral of that story there is that in order for pieces to cancel on top and bottom, they must be attached by multiplication. Multiplication is good. Adding and subtracting are the enemy. They are what is going to make you not be allowed to cancel something on top and bottom that you're really going to want to cancel, all right? All right, so these are the steps that you have to follow. If multiplication is good, then what we need to do is make sure that everything is attached by multiplication. And how do we break things up into pieces that multiply and get things attached by multiplication? We have to factor. So step 1 in all of these problems is don't cancel. Don't look to see what cancels. Factor the top and bottom. If it's possible, then you can cancel or reduce on top and bottom. You want to cancel out like factors. Okay, and again, the more examples you see, the easier this is going to be, all right? So it's just going to take some practice. And one of the major things you're going to have to practice is your factoring again, all right? So hopefully you have your factoring checklist still. All right, but here, let's jump in. Let's try one. So the directions say to simplify or reduce the following rational expressions. So basically, we're simplifying or reducing the following fractions. All right, so if you look at this one, guys, look at all this adding and subtracting. That's so bad for us because your brain at first is going to look like, oh, x squared and x squared. Cancel, cancel. No. All of this adding and subtracting holds the top together as one package. And x squared plus 8x plus 7 could only cancel with another x squared plus 8x plus 7 with another expression that looked just like it. This is a package deal and they have to stay together. All right, and then you're dividing it by, look at all this adding and subtracting. All of that adding is keeping this together as one package. So an x squared plus 10x plus 21 could only cancel or reduce with another x squared plus 10x plus 21 on top. All of this adding and subtracting right now is bad for us. So what we need to do is try and get things attached by multiplication, okay? So we're gonna look to factor the top and factor the bottom. Okay, when we go to factor, we look for a GCF first. Does an x squared, 8x, and 7 have a greatest common factor? No. Is it the difference of two squares? No. Is it grouping? No. Is there a number in front of x squared? No. So these are the easiest ones to factor. So give yourself some factors, pieces that multiply, and let's see what we can do. Well, we know when we factor, whatever we put in the first spot and the first spot has to multiply to x squared. So what times what will multiply to x squared? X. I know whatever number I put here and here has to multiply to 7, and then my rainbows have to add up to the 8x's in the middle. Well, guys, the good news for us is, what are the only numbers in the world that multiply to 7? 7 and 1. So because it's just x and x, you can put them in any order. 7 and 1. So now that'll get you 7x's, and that'll get you 1x. 7x and 1x can add up to 8x's. Now let's work the signs. What signs do I need to multiply to that 7 and add up to a positive? I need a plus and a plus. Okay, so that works. X times x gets me x squared. Positive 7 times positive 1 gets me positive 7. 7 times x is 7x's. X times 1 is 1x. 7x and 1x add up to 8x's in the middle. So that's right. All right, divided by, and now look, that is multiplication right there. So now I'm going to be able to take an x plus 7 on top and bottom and cancel it out. I'd be allowed to take an x plus 1 on top and bottom and cancel it out, because now this package and this package are attached by multiplication, okay? All right, let's factor the bottom. All right, so I'd look for a GCF. There isn't one. It's not the difference of two squares. It's not grouping. There's no number in front, so I can go right to my factors. All right, what times what gets me x squared, x, and x, and now whatever number I put here and whatever number I put there better multiply to 21, and then my rainbows better add up to the 10x's in the middle. Well, guys, there's not many numbers that multiply to 21, so what numbers could we use? 1 and 21 or 7 and 3, and which ones have a shot of adding up to 10? 7 and 3. So I'll put 3 here and 7 there. It does not matter. 7, 3, does not matter. All right, and then if I have to multiply to a positive 21 and add up to a 10, I need a plus and a plus. All right, let's check my factors. X times x gets me x squared. 3 times 7 gets me 21. 3x's and 7x's get me 10x's in the middle. Okay, so now this package and this package are attached by multiplication. So now that I have factors, I can cancel out if I have any of the same factors on top and bottom. So now what happens to an x plus 7 on top and an x plus 7 on bottom? They divide out. They cancel. All right, and then that's going to leave you with an x plus 1 on top over an x plus 3 on bottom. And if you think you're going to be tempted to cross these x's out, you cannot. Remember, x plus 1 is a package. Leave it in parentheses to remind you that an x plus 1 would only cancel with another x plus 1 on bottom. All right, and then again, x plus 3 is a package. It would only cancel with another package of x plus 3 on top. All right, so again, if you feel like you might be tempted to cross these x's out in the end, then leave them in parentheses to remind yourself that you can't. All right, so whether you write it like this or like that, you're correct. That is your reduced fraction. So again, you might be like, oh, why do I have to do this? Well, if in math you're working with expressions, would you rather work with this problem or would you rather work with this problem? This is going to be much easier to work with and plug numbers in and out of than this one. And this equals him. This is just a reduced version of that big fraction, okay? All right, let's try another one. So again, this just takes time. All right, so look here. Look at all this subtraction and adding, right? So right now, because of all of this subtraction and adding, the top is held together as a package. So x squared minus x minus 30, it could only cancel if you had another x squared minus x minus 30 on the bottom, right? And then all of this subtraction and adding is holding the bottom together as a package, right? They want you to look at this and they kind of want you to get like cross out crazy. They want you like, oh, cross these out, cross my x's out, but you can't because of all of the adding and subtraction subtracting. So what we need to do is factor. Get things attached by multiplication first. All right, so let's factor our top and let's factor our bottom. Look for a GCF. There isn't one. It's not the difference of two squares. It's not grouping. There's no number in front, so it should be easier to factor. All right, so what times what gets me x squared, an x and an x, and then whatever numbers I put here better multiply to negative 30, and my rainbows better go to negative 1x. Well, guys, what numbers do you multiply to 30? Because those are the only ones you can put in here, right? So you got 10 and 3, you got 2 and 15, you got 5 and 6 and whatnot. That might be it right now. All right. Oh, 30 and 1. Okay, so guys, you tell me, which one of these numbers have a shot of adding up to that negative 1 right there? It's got to be the 5 and the 6, right? So in any order, it doesn't matter, 5, 6, and now let's work the signs. What signs do you need to multiply to that negative 30 and add up to that negative 1x? I need a negative 6 and a positive 5, right? That'll multiply to a negative, and then 5x and negative 6x's get me negative 1x. All right, let's factor the bottom now. All right, again, because now these two packages are attached by multiplication, and multiplication is our friend. All right, here we go. Let's factor the bottom. No GCF. It's not the difference of two squares. It's not grouping. There's no number in front. So give yourself some factors. What times what get me x squared? X. Whatever number I put here and here better multiply to 24, and then my rainbows better add up to those negative 10x's. So what numbers could I put here? Well, what numbers do you know multiply to 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Who's got a shot of going to 10? Well, technically there's 2 and 12 and 4 and 6, right? But if I have to multiply to a positive, I either need negative, negative, or positive, positive. Positive, positive won't add up to 10. Negative, negative won't add up to 10. So it can't be them. It's got to be the 4 and the 6. So in any order, let's put the 4 and the 6. Does not matter, okay? So now, what signs do I need? Well, how do I multiply to a positive but then add up to a negative? I must need a minus and a minus. All right, let's double check it. X times x gets me x squared. Negative 6 times negative 4 is 24. Negative 6x's and negative 4x's get me my negative 10x's. So now that I have all of these factors, pieces attached by multiplication, now I can cross off the same factor on top and bottom. So what happens to an x minus 6 and an x minus 6? They cancel. And I'm left with x plus 5 over x minus 4. And like I said, if you think you're going to be tempted to cross off those x's and you can't, then leave them in parentheses to remind yourself that that's a package. That's a done deal, okay? And you're done. All right. All right, let's try more. Again, to me, I feel like the harder part is just getting back to your factoring. All right. All right, look at this one, right? Look at all this adding and subtracting. So the top is being held together and it's being divided by the bottom that's being held together. Again, they want you to get like cross out crazy. They want you to be like, oh, cross that out and reduce the 16 and the 4. But you can't because these are packages. They are being held together by all of this adding and subtracting. So we got to factor. So let's factor the top and factor the bottom. All right, so if I factor the top, right? There's no GCF, it's not the difference of two squares, it's not grouping, there's no number in front, so what times what gets me x squared? An x and an x. Whatever number I put here and here better multiply to negative 16, and then my rainbows better add up to 6x's. Well guys, what numbers do you know multiply to 16, right? You got 1 and 16, you got 4 and 4, you got 2 and 8, and I think that's it. Who could go to that 6 that we need? The only shot we have are the 8 and the 2. So in any order, give me an 8 and a 2. What signs do we need to get a negative 16? So I need a plus and a minus, and then I need 6 x's. So I must need a positive 8 and a negative 2, right? Positive 8 x's, negative 2 x's get me my positive 6, and they get me my negative 16. All right, over, all right, x squared minus 4. Well, we always look for a GCF first, right? But it doesn't have one, so we're stuck factoring this. So it should look small. So bells, whistles, sirens, neon flashing lights should be going off in your head. That's the difference of two squares, right? And the difference of two squares always factor. 2 the same two factors except one's plus and one's minus. So just take your square roots. What's the square root of x squared? I need an x and an x. What's the square root of 4? I need a 2 and a 2, right? They always factor to the same two factors except one's going to get a plus and one's going to get a minus. All right, perfect. So now x times x gets me x squared, 2 times negative 2 gets me negative 4, and then 2x and negative 2x's add up to the 0 x's we have in the middle. All right, so now that we have this factored and we have pieces attached by multiplication, I can cancel out those like factors. So x minus 2 and x minus 2 will cancel, and you'll just be left with x plus 8 over x plus 2. And again, if you think you're going to be tempted to cancel those x's out, then leave them in parentheses so you remember this is a package and this is a package. And you're done. Okay? All right, look at this one. X squared minus 9 divided by x squared minus 5x minus 24. Look at all this subtraction, guys. It's keeping things together as packages, right? So we need to factor this. So let's factor the top and let's factor the bottom. So x squared minus 9, no GCF, but I hope you recognize that's the difference of two squares. So he's going to factor to the same two factors except one's plus and one's minus. So what times what that is the same gets you x squared, right? Take your square root. It's x and x. And now what times what that is the same number multiplies to 9. Take your square root and it's 3 and 3. And then we need a plus and we need a minus. Okay? All right, let's go to the bottom. Now I factor this. There's no GCF. It's not the difference of two squares. There's not grouping and there's no number in front. So at least it should still be easy. All right? So what times what gets me x squared? X and then I need to put a number here and a number here that multiplies to negative 24, and then I need my rainbows to add up to negative 5x's. Well, guys, give yourself some options. What numbers could you put here? What numbers do you know multiply to 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of these numbers could get you that 5? Only the 3 and the 8. So let's see what we got. 3 and 8, let's work the signs. How am I going to multiply to a negative? I need a plus and a minus then, and I got to add up to those negative 5x's. So that means I must need a minus and a plus, right? That's going to be multiply to negative 24, and then 3x's and negative 8x's will add up to those negative 5. So now what's going to happen to your x plus 3 and your x plus 3? They'll cancel. And you're going to be left with x minus 3 over x minus 8. And you can leave it like that, but if you think you're going to be tempted to cross things out that don't cross out, leave them in parentheses to remind you that they're a package deal, okay? And you're done. All right, last one. All right, 2x squared minus 15x minus 27. Look at all that subtraction, right? It's holding all this together like a package. This could only cancel if you had the same expression written on the bottom, right? All right, and then x squared minus 81, that's a package. So we need to factor this. All right, so here we go. I don't like that 2 in front, but here we go. I'd look for a GCF first. But a 2x squared, a 15x, and a 27, they don't have one, all right? So give yourself some factors, all right? It's not the difference of two squares. It's not grouping, but there is a number in front. But lucky for us, it's a good number. Think about it. Whatever you put in the first two spots, they have to multiply to 2x squared. Well, guys, what are the only numbers that multiply to 2? 2 and 1. So you need a 2x and a 1x. Those are the only numbers you could have put there to get you that 2x squared. All right, now whatever number I put here and whatever number I put here better multiply to negative 27, and then my rainbows better add up to those negative 15x's. So guys, give yourself some options. What numbers do you know multiply to 27? Well, there aren't a lot. It's 1 and 27, or it's 3 and 9. So pick your favorite, right? Because we have to kind of work the rainbows a little bit. I'm going to go with 3 and 9 first. So guys, let me just get a pencil. If I put let's just say I put, I want to try and do it wrong first. If I put a 3 here and a 9 there, right? That gets you 9x's, and that'll get you 6x's, right? Wait, did I want to do that? Okay, so now 9x's and 6x's. Could they go to 15? Yeah, they could. but hold the phone, guys. This is one of those ones that looks like you have it, but you don't have it. Because if I have to multiply to a negative 27, what signs do these numbers have to be? One's a positive and one's a negative. So if one is positive and one is negative, they'll never go to a 15. They're going to go to some 3 or negative 3. So that's actually not the right answer. So let's switch it up. Let's try it the other way. And let's try the 9 here and the 3 there. Okay, so that's going to get you 3x's. That's going to get you 18x's. Now, can 3x's and 18x's go to a 15? Yes. And now one can be positive and one can be negative, and they'll still go to that negative 15. Well, guys, if I want to go to a negative 15, I'm going to need a negative 18 and a positive 3. So that means I'm going to need a negative 9 and a positive 3. Okay? All right, let's double check that. Okay? All right. 2x times x is 2x squared. Positive 3 times negative 9 is negative 27. 3x's and negative 18x's get me my negative 15x's that I need. All right? Perfect. So that factored right, so I can lock that in. Plus 3 minus 9. Okay. All right, over. Now we have to factor the bottom. Well, there is no GCF and he's tiny. So again, bells, whistles, sirens, neon flashing lights. That's the difference of 2 squares, guys. So give yourself 2 factors. They always factor to the same 2 factors, right? Except one's positive and one's minus. So what times what that is the same gets you x squared? Well, you can use your square roots. I need an x and an x. All right. And then what number times the same number gets you 81? We'll use your square roots, and it's 9 and 9. And then I need 1 plus and 1 minus in order to multiply to that negative 81 and add up to those 0 x's I have in the middle. All right, good. So now we factored it. So now you can cross out same factors on top and bottom. So now what's going to happen to an x minus 9 and an x minus 9? Now they cancel. And you're just left with 2x plus 3 over x plus 9. And again, if you think you're going to be tempted to cross those x's out or reduce that because you're not allowed, then leave them in parentheses to remind yourself they are a package and you cannot cross them out. And you're done. Okay? All right, guys, I know that was long, but like I said, you kind of gotta get back into the swing of things with factoring, and I don't want you making any silly mistakes. So just remember, adding and subtracting are bad. We need things to be attached by multiplication, okay? All right, as always reach out to me, text me if you have any trouble. I'll be more than happy to help you. And then your homework will be on Delta Math for the first time, for the first assignment on this, okay? All right, again, good luck, and reach out to me if you need help.